Hi guys, welcome to mathematics platform. Today we are going to learn about gradient and equation of straight lines. The specific objectives of this topic are: by the end of the topic, the learner should be able to define gradient of a straight line, determine the gradient of a straight line through known points, determine the equation of a straight line using gradient and one known point. Express a straight line equation in the form y equals to mx plus c. Interpret the equation y equals to mx plus c. Find the x and y intercepts from an equation of a line. Draw the graph of a straight line using gradient, x and y intercepts. State the relationship of gradient of perpendicular lines. State the relationships of gradients of parallel lines. And apply the relationship of gradients of perpendicular and parallel lines to get equations of straight line. Be with me in this lesson as we learn. Thank you. I'd like to remind you about what you learned in Form 1 coordinates or points, whereby you were told that coordinates are in the form xy. And also in the topic of simultaneous equations, you also learned to solve simultaneous equation graphically, and you were able to draw straight lines. Those straight lines that you drew are in the form y equals to mx plus c. Whereby if you drew a line like this one, the point where it cuts the x-axis, this point is the point we call C. That is the y-intercept, is what we call C. C is our y-intercept in this equation. Gradient is the steepness or slope of an area. Gradient can also be said as the change in the y-axis over the change in the x-axis. Change in y-axis over the change in x-axis. If you're asked to find the gradient of a line like this one, if I let this point to be x2 and y2 and this one to be x1 and y1, the gradient of this is y2 minus y1 over x2 minus x1. That is how you find the gradient of points, the change in y-axis or the change in x-axis. Some points you need to know about gradients is that when there is a positive gradient, it means there is an increase in y-axis which causes corresponding increase in the x-axis. That line has a coordinate, has a gradient which is positive. And a gradient, a line with a negative gradient, is an increase in the x-coordinate causes a decrease in the y-coordinate. That gradient is negative. And for a line that is parallel to the x-axis, a line parallel to the x-axis, an horizontal line here, it has a gradient that is 0. That means an increase in the x-coordinate, there is no change in the y-coordinate, and therefore the gradient is 0. For a vertical line, that is a line parallel to the y-axis, vertical line here, the gradient is undefined. The gradient is undefined, that is, it is infinite. We want to do some examples. 1. Find the gradient of the line that passes through points 2, 3 and 6, 4. If I sketch the line or I draw the line at point 6, 4 and point 2, 3, the gradient will be the change in y-axis or a change in x-axis, which is 4 minus 3 all over 6 minus 2. And 4 minus 3 is 1, 6 minus 2 is 4. And therefore the gradient of the line is a quarter. How do we find equation of a straight line when we are given 2 points? Example, find the equation of the line through the points A, 1, 3 and B, 2, 8. The first thing we do is to find the gradient of this equation. The gradient is the change in y over the change in x, whereby it will be 8 minus 3 over 2 minus 1, which will be equal to 5. Now, there are many ways or methods of solving this, but I'll stick to one method, whereby I let a point xy, another point xy, apart from the point you are given. You let another point xy to be on the same line, xy to be on the same line. And therefore, that point you've let xy, you start now changing y-axis, you take one of these points, like in this case, I'll use 1, 3. So, gradient will be y minus 3 over x minus 1. And that gradient will be the same at end point. Therefore, y minus 3 over x minus 1 will be equal to the gradient that we got, which is 5 over 1. I've put over 1 because I want to maintain it in fraction form for easy manipulation. Therefore, you cross multiply, it will be 1 into y minus 3, 1 into y minus 3, which is equal to 5 into x minus 1. And therefore, you open the bracket, it will be y minus 3, which is equal to 5, x minus 5. You like terms together, you put like terms together, it will be y equals to 5x minus 5 plus 3, and therefore y equals to 5x minus 2. That is our equation. When we are given the gradient and 1 point on a line, how do we find the equation? Example, determine the equation of a line with gradient 3 passing through points 1, 5. We have gradient 3 and it's passing through points 1, 5. Now that we have the gradient, the only thing we do here, we let another point x, y to be on the same line. And therefore, y minus 5 over x minus 1 will be equal to this gradient, which is 3 over 1. You put in fraction form for easy manipulation. You cross multiply, it will be 1 into y minus 5 equals to 3 into x minus 1. Which, when you open the bracket, will be y minus 5 equals to 3x minus 3. Whereby you put like terms together, we shall have y equals to 3x minus 3 plus 5. Hence, y equals to 3x plus 2 is our equation. It is in the form y equals to mx plus c. Always remember to put in that form unless told otherwise. How do we express a linear equation in the form y equals to mx plus c? Example, express 4x plus 3y equals to negative 8 in the form y equals to mx plus c. The only thing you need to know here is to rearrange the equation in the form y equals to mx plus c. So, whereby y has no coefficient and x has a coefficient of m. So you ensure that your equation is that form. How? If we take all 4x to the right hand side, we shall have 3y equals to negative 4x minus 8. 4 was positive, becomes negative, minus 8. You divide by 3 all through, you will have y equals to negative 4 over 3x minus 8 over 3. This is the form y equals to mx plus c. In simple terms, there is no work here, it's just rearranging the equation given. Example 2, find the gradient of the line whose equation is 3y minus 6x plus 7 equals to 0. So this one is all that we have been doing, like what we have done from above. what you do, you rearrange this in the form y equals to mx plus c, and therefore you are able to give the coefficient of xm as the gradient. So you take 6x to the right hand side and 7 to the right hand side. It will be 3y equals to 6 is negative becomes positive equals to 6x minus 7, because 7 was positive here, it becomes negative. So we shall have 3y equals to 6x minus 7. You divide by 3 or 2 so as to get the form y equals to mx plus c. Remember, y has no coefficient, and therefore we divide by 3 or 2. So we get y equals to 2x minus 7 over 3. And our m is the coefficient of x, which is 2 in this case. And therefore, the gradient of this line is 2. How do we find y and x intercepts? In my sketch here, this is a straight line here. It cuts the y-axis at this point. It cuts the y-axis at point A, which is the y-intercept in this case, and cuts the point, the x-axis at point B, which is our x-intercept. And therefore, what you notice that if at this point A, what is the value of y, of x? At point A, the value of x is 0. And at point B, the value of y is 0. And therefore, at y-intercept, x is 0. And at x-intercept, y is 0. That is what you need to know. After understanding all that, you are able now to find the x and the y-intercepts. Example, find the y-intercept of y equals to 2x plus 10. To find the y-intercept, we know that at y-intercept, x is 0. So we substitute the value of x with 0 here to get the value of y. If we substitute 0 here, 0 times 2 is 0, and therefore y equals to 10. So the y-intercept is y equals to 10. And the x-intercept, we know at x-intercept, y is 0. So here we substitute y with 0. So it will be 0 equals to 2x plus 10. We bring 10 this other side, it will be negative 10 is equals to 2x. You divide by 2 all through, you get that x equals to negative 5. X equals to negative 5. X equals to negative 5. That is the x-intercept. Simple as that. That is how we find the intercepts. Drawing a graph using the x and the y-intercepts. We learned in Form 1 on how to plot points. Now that example here, we are given that draw a line graph given the y-intercept as 6 and the x-intercept as 4, as negative 4. We know that y-intercept being 6, the value of x is 0, and therefore the point at that point here, it is 0, 6. And when given the x-intercept as negative 4, we know the value of y is 0, and therefore the point is negative 4, 0. To plot point 0, 6 and point negative 4, 0, you just have a good scale in your Cartesian plane, and then you plot the point 0, being x is 0 here, and y is 6 here. You plot that point. You also plot a point x being negative 4 here, and y being 0. And therefore, after plotting the 2 points, you join them using a straight line, using a ruler. And therefore, that is how you draw a straight line graph using intercepts. We want to talk about perpendicular lines. We need to know some of the characteristics of perpendicular lines for us to understand on how to do the manipulations. Some of the characteristics of perpendicular lines are the lines, when the lines intersect, where they intersect, they form right angles. They form 90 degrees here. Like this line, the red line and the blue line, they intersect, both are perpendicular. They intersect here. Whatever they find, the angle they form here is 90 degrees. When they intersect, they form 90 degrees. Where they cut each other, they form 90 degrees. Another characteristic is that the product of a gradient of this line and the gradient of this blue line would give you -1. That is, if the two lines are perpendicular, their gradient must give you -1. If they don't give you -1, then that means they are not perpendicular. Example, find if the two lines are perpendicular. One line is y equals to a third x plus 1 and y equals to -3x minus 2. Now what we do, we let if this is m1, the gradient of the first line as m1 and the gradient of the second line as m2. We know that m1 times m2 equals to -1. So we need to multiply the two gradients a third times -3. If it does not give -1, then they are not perpendicular. If they give -1, they are perpendicular. A third times -3 gives you -1, and therefore the two lines, this and this line, are perpendicular. In my example here, we have two lines here. It's a red line and a blue line. The two lines are parallel, and these two lines are parallel. Characteristic of parallels is that they are always the same distance apart and never touching. The distance from here to here is uniform. From here to here is the same, from here to here is the same, from here to here is the same. That distance is uniform and they never touch. Even if they move from whichever side, they will never meet. These lines, the distance from here to here is the same, from here to here is the same, and they will never meet. And they also point at the same direction. That's another characteristic. They point at the same direction. They are pointing towards this direction. These who are pointing towards this direction, they mean they are parallel. And because of that, they have same distance in between, they point same direction. That means they have the same gradient. An example, y equals to 2x plus 7 and y equals to 2x minus 9. They are already arranged in the form y equals to mx plus c. The gradient of this equation is 2 and the gradient of this equation is 2. And now that they have the same gradient, that means the two lines are parallel. Some points to note about parallels and perpendicular lines and about this topic is that perpendicular bisector, when you hear of the term perpendicular bisector of 2 points, that means for you to know where they bisect each other, where the perpendicular bisect the line, you need to find the midpoint. For instance, if you are given a point 2,3 and a point 4,5, to find the point where the bisector, the perpendicular bisector will bisect that, where it will pass, where it will cut the line, the point at which the line will be cut, we find the midpoint. And to find the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. And therefore, the midpoint of 2 and 3 and another point 4, 5 is 2 plus 4 over 2 and 3 plus 5 over 2. That gives you the midpoint, which is 6 over 2 is 3 and 8 over 2 is 4. So the midpoint is 3, 4. So whichever situation where you are told about a perpendicular bisector, think about finding the midpoint. Another point you need to know is that when you hear of a term, a line that is equidistant, if you have a point and another point, a line that is equidistant means that a line perpendicular to those 2 points, to that line given. It means a line that is perpendicular to that line given. And therefore, and that line must, that line which is equidistant, must cut it at the mid-draw. And therefore, you also need to find the midpoint at that point. Another point that you need to note is that sometimes you might find an equation asking you about an angle that a line makes with the x-axis. An angle line makes with the x-axis. When you're told about an angle a line makes with x-axis, you need to think about the tangent. And therefore, the tangent of that angle equals to the gradient of the line given. The tangent of the angle that is made at the x-axis equal to the gradient of the line. As an example, if we are given a point 2, 3 and a 4, 5 as the line, and we want to find the angle this line makes with the x-axis, first of all, we need to find the gradient of this line, which will be 5 minus 3 over 4 minus 2, that is 2 over 2, which is 1. And therefore, the angle the line makes with the x-axis, it implies that tan of theta equals to 1. For us to find theta is the tan inverse of 1. Tan inverse of 1, which will be equal to 45. To find tan inverse, if you are using a calculator, you shift, you press tan, then you get, you press 1, then you get 45 degrees. Or use a mathematical table to find the tan inverse of 1, you get as 45 degrees. That is, if we are confronted with that situation, where you are finding the angle that is made by the line at the x-axis, that is what to do. Another thing you need to know is that to find point of intersection of two lines, when you are given two lines and you are asked to find the point of intersection, that is, you find where the two lines met, what you do, you solve the two equations given simultaneously. If you solve the two equations given simultaneously by using either elimination method or substitution method or another method, you find the point of intersection where the two meets. Now we want to do application questions because we are done with the topic. That is all that you need to know. Now we go to application questions and do some of the questions that you expect to know for you to understand better this topic. Question number 1. A line L1 passes through the point 1, 2 and has a gradient of 5. Another line L2 is perpendicular to L1 and meets it at a point where x is equals to 4. Find the equation for L2 in the form y equals to mx plus t plus c. The form you are told is very essential, and it is not always that you are told to write it in this form. The form can change, and therefore always remember to write your answer, the final answer, in the form given. Otherwise, you lose the answer mark. In this question, we need to find the equation of L1. We need to find the equation of L1, of the line 1, whereby line 1, we are given the gradient and 1 point, and we know how to do it. We have done it. So the gradient we're given here is 5, and another point is 1, 2. We said that you let another point on the line 1, 2, on the line with point 1, 2 to be xy. So if you let another point to be xy, so it means y minus 2 all over x minus 1 will give you the gradient, which is 5. I said you put over 1. So 5 over 1 equals to y minus 2 over x minus 1. You cross multiply. That means you start with the side with y because you want your y to be on the left hand side. So 1 into y minus 2 equals to 5 into x minus 1. You open the bracket, it will be y minus 2 equals to 5x minus 5. Because you want the form y equals to mx plus c, you maintain y on the left hand side, and therefore y will be equal to 5x minus 3. That is the equation of L1. But remember, that's not what we are finding. We are finding the equation of L2. And we know that L2 is perpendicular to L1. And we know for perpendicular lines, M1 times M2 equals to negative 1. M1 times M2 equals to negative 1. But remember, L2 and L1, they meet at a point where x is 4. If x is 4, that is where they are meeting, where x is 4, we substitute in the equation that we have found, because they meet there. If we substitute this 4 and this x with 4 here, we will find the value of y, and therefore 4 times 5 minus 3 gives you 17. So the point of intersection will be 4, 17. Point of intersection will be 4, 17. That is the point of intersection. That is where line L1 and L2 meet. And this is the point that we can use to find the equation of the perpendicular line, which is L2. The equation of that perpendicular line to the other one, which is L2. So, and we know m1 times m2 is -1, and therefore 5 times m2 equals to -1. And therefore m2, that is if you divide by 5, will be equal to -1 over 5. -1 over 5. That is a fifth, -1 over 5. So we use the point 4, 17 that we are given, and we read another point xy to be on that line L2. And therefore 7y minus 17 all over y minus 17 all over x minus 4 will give you the gradient that we have found for that perpendicular line, which is -1 over 5. So -1 over 5 equals to y minus 17 all over x minus 4. You cross multiply, you start with this with y, so that you have it on your left hand side. So 5 into y minus 17 equals to -1 into x minus 4. You open the bracket, you'll get as 5y minus 85, because 5 times 17 is 85. 5y minus 85 equals to negative this times x. -1 times x gives you -x. Negative x times -4 gives you positive. So it will be -x plus 4, which means that 5y, like terms together, equals to -x plus 89. 89 because we brought 85 to the right hand side to give you 89. 85 plus 4 is 89. Therefore 5y equals to -x plus 89. To have it in the form y equals to mx plus c, remember y has no coefficient, so we divide by 5 all through, and therefore you get your equation as y equals to -50x or -x over 5 plus 89 over 5. That is the equation of L2 in the form y equals to mx plus c. Question 2. Find an equation of the line that passes through the point -2 and 3, and that line that is passing through this is parallel to the line 4x plus 4y equals to 8. You find the equation of a line that is passing through this point, and this line passing through this point is parallel to the line passing through this point, through this line. It's parallel to this line. So what we do, first of all, we have to find the gradient of this equation. So what you do, you rearrange this equation in the form y equals to mx plus c. So you maintain the left hand side for the 4y on the left hand side, you take this to the right hand side. So it will be 4y equals to, this becomes negative on the right hand side, equals to -4x plus 8. You divide by 4, and therefore y equals to -x, because -4 divided by 4 is 1, -x plus 2. 8 divided by 4 is 2, plus 2. That is the equation, this equation in the form y equals to mx plus c. And therefore our m, that is the coefficient of x here, is -1. So our coefficient of x is -1. And therefore, since they are parallel, like we are told they are parallel, since they are parallel, we know that m1 equals to m2. That is our M2 now, that that line that will pass through here will be equal to -1. The gradient will be -1. If the gradient will be -1, we now let another point xy to pass through this line, align with this point xy to pass through here, meaning that y minus 3, if we are finding the gradient, y minus 3 all over x minus minus 2, which means x plus y minus 3 all over x minus minus 2 will be equal to -1 over 1. I said just write in fraction form, put it a fraction for easy manipulation so that you are able to see. So remember, this one negative becomes positive. So what you do, you cross multiply. You start with the one with y because you want your y to be on the left hand side. So it will be 1 into y minus 3 equals to -1 into x plus 2 or into x minus minus 2. Y minus 3 will be equal to that one, will be equal to -1 into x minus minus 2. So that means y, we leave it here, the left hand side. If we leave the y on the left hand side so that we have the like terms together, we shall have y equals to -x. If you open here, it becomes -x. Negative times this is positive. Remember, it became positive, so it becomes -2. So y equals to -x minus 2 plus 3. This was negative. You bring it to the right hand side, it becomes +3. So y equals to -x minus 2 plus 3. -2 plus 3 gives you +1. Therefore, the equation is y equals to -x plus 1. This is the equation of a point, of a line passing through this point. That is the question we are asked. The equation is y equals to -x plus 1. Question number 3. A straight line L1 passes through the point -1 and 3 and 11, 12. It's a line that is passing through -1, 3 and 11, 12. The first question from that is that we find an equation for L1 in the form ax plus by plus c equals to 0. Remember, now this is not the form we are used to. This is a different form. And you must ensure your answer is in this form, because if you want to get that 1 mark for the answer, you must ensure it is in the form asked. So what we do here, the first thing we do, we find the gradient. You know, the first step is to find the gradient of the 2 points. Then from there, we let another point xy to be on the same line. From there, we find the equation. So the gradient will be 12 minus 3 all over 11 minus minus 1, which is the same as 11 plus 1. So it gives you 12 minus 3 is 9, and 11 minus minus, this is positive, it gives you 9 over 12. You simplify it, you get 3 over 4. That is the gradient of the line passing through the 2 points. Now we let another point xy to be on the same line, and therefore y, you can pick endpoint to use. You can either use this one or this one. If I decide to use this one, I'll say that y minus 3 all over x minus minus 1, because this is negative. X minus minus 1, which is the same as x plus 1, will be equal to the gradient, because gradient is the same, gradient of a line is the same at endpoint. So it will be equal to 3 over 4. You cross multiply. I said you start with the one with y, so that you maintain it on your left hand side. So it will be 4 into y minus 3 equals to 3 into x plus 1. This, you open the bracket, will give you 4y minus 12 equals to 3x plus 3. Remember, the form you are told is ax plus by plus c. So therefore, remember, this is the equation already, but write it in this form, in the form given. So what you do, you start with x. You bring this to the left hand side, you bring, or if we maintain this one the way it is, 3x, what we do, we bring y here, it will be minus 4y, then we bring 12, it will be plus 12, so it is 0 remains here, so we have 3x plus minus 4y plus 3 plus 12, that gives you 15. So we shall have 3x minus 4y plus 15 equals to 0. You've rearranged in the form ax plus py plus c form. This is the form you are asked. If you asked in the form y equals to mx plus c, it could be still easier, like we have solved from above. Part B, the line L2, we know another line L2 has the equation this. This is a line L2 with this equation. Find the coordinate of a point of intersection of L1 and L2. So, because we are asking about point of intersection, what we do, I said we solve this, and the equation that we have found, we solve them simultaneously. So this is the first equation. I want to use the elimination method to solve the two equations simultaneously. This equation, you rearrange x. Remember here, this equation is y. So I've just rearranged with 4x to start, plus 3y, then minus, I've taken 30 on the right hand side. So 4x plus 3y equals to 30. And this one I've also rearranged to be 3x minus 4y equals to negative 15. So I've rearranged the two equations in this form for easy manipulation. Now I want to eliminate x. To eliminate x, you know that you multiply the coefficient of x of the lower equation on the upper, and you also multiply the coefficient of x of the upper equation with the lower. Like I've done here, you multiply with the same, you find 4 times 3, it gives you 12x minus 16y. Minus 16y, 4 times 4 is 16y, equals to negative 60. 4 times 15 is negative 60. And we also have 3 times 4 is 12x plus 9y equals to 90. So what you do, for you to eliminate here, to get a 0 on x, we subtract. If we subtract, we shall have negative 16y minus 9y. Negative 16y minus 9y, you get negative 25y. Negative 60 minus 90, you get the negative 150. You divide by negative 25 all through, you find y equals to 6. Y equals to 6. So what you do now that you have found y equals to 6, you go to end of the original equation, either this equation or this equation, you substitute your value of y there to find the value of x. I've decided to use this equation. I substitute wherever I have a y, I substitute with 6. So I shall have 3x minus 24. 24 is 4 times 6 is 24. So gives you 24 minus 24 in that one, plus 15 equals to 0. So you find that 3x equals to 9, because this one gives you 9. Negative 24 plus 15 is 9. So 3x equals to, it is negative 9. You take the other side, it becomes positive 9. So 3x equals to 9, and therefore x equals to 3. So the point of intersection, that's the question, is our x is 3 and our y is 6. So the point of intersection is 3, 6. Our question number 4 is that we have a point P, which is 5, negative 4, and a point Q, which is negative 1 and 2. Those are points on a straight line. Find the equation of the perpendicular bisector of PQ. You find the equation of the perpendicular bisector of PQ. Then you give your answer in the form y equals to mx plus c. I gave you points to note. And one thing I told you is that when you hear of the term perpendicular bisector, it means it's a straight line that is going to pass at the middle of the 2 points given, at the middle of the line given. So what we do, we find the midpoint of the line given. And the midpoint I said is x1 plus x2 over 2 and y1 plus y2 over 2, which gives you 5 plus minus 1 is the same as 5 minus 1 over 2, and negative 4 plus 2 over 2, which gives you 2, negative 1. That is the midpoint. So if I have the midpoint, this is where that line is going to pass. So I let another point xy to be on this line, where this perpendicular line, to be on this line with 2 and negative 1. So it could be the gradient, that is, remember the gradient of this line, because they are perpendicular. They are perpendicular. So the gradient of this line, first of all, we find 2 minus 4 all over negative 1 minus 5. This gives 6 over negative 6, which is 1 over negative 1. Remember, m1 times m2, when they are perpendicular, equals to negative 1. So this one, negative 1, this is negative 1, the gradient is negative 1 times m2 equals to negative 1. So you divide by negative 1 all through, it gives you m2 as what? As 1 positive. And therefore I said you let another point xy to be on the line with 2 negative 1, with 2 negative 1, and therefore y minus minus 1, y minus minus 1 all over x minus 2 equals to the gradient that you have found, which is 1. You put in fraction form, 1 over 1. You cross multiply, it will be, remember this positive, it will be y into y, 1 into y plus 1 equals to 1 into x minus 2. So y plus 1 equals to x minus 2. Therefore, we go like terms together, y will be equal to x minus 2 minus 1, and therefore y equals to, remember minus 2 minus 1 is negative 3, and therefore y equals to x minus 3. This is in the form y equals to mx plus c, and that is the equation you are asked. Another question is that we find the equation of a straight line which is equidistant, from the points 2, 3, and 6, 1. Expressing it in the form ax plus by equals to c. This is another form. So the form must not always be y equals to mx. That's the form of a straight line, but the question, you answer the question the way it is asked. So this is the form you are asked to put your answer, and ensure it is in this form, otherwise you will miss that 1 mark. And where a, b, and c are constants. So what we do first, when you have the term equidistant, I said from the onset that equidistant means it is perpendicular and it's passing at the midrow. So we need to find the midpoint where it will pass. So the midpoint where it will pass, it is 6 plus 2 over 2, and 3 plus 1 over 2, which is 4, 2. That is where it will pass. So what we do, we find the gradient of this line, of the first line, which is 1 minus 3 all over 6 minus 2, which will be equal to this one, 1 minus 3 is negative 2 all over 4, negative 1 over 2. That is my gradient. And I know, because they are perpendicular, m1 times m2 must be equal to negative 1. And therefore, negative 1 over 2 times m2 equals to negative 1. So to get my m2, I times the reciprocal of this, which is m2 equals to 2 all over negative 1 times negative 1, which gives you 2. So my m2 is 2. So we let another point xy to be on the line that is will pass through 4 to this point. So y minus 2 all over x minus 4 equals to the gradient that I have found, which is 2 over 1. So I cross multiply, I start with whichever this side, which is 1 into y minus 2 equals to 2 into x minus 4. So y minus 2 equals to 2x. 2 times this is x. 2x minus 8. 2x minus 8. Therefore, y equals to 2x minus 6 when you like terms together. Because negative 2 becomes positive. Negative 8 plus 2 is negative 6. So y equals to 2x minus 6. But remember, the form you were asked is ax plus by equals to c. And therefore, I bring this, if I remain, I bring 6 on the left-hand side, I take y this other side, it will be 2x. 6 becomes here equals to 2x minus y. So 2x minus y equals to 6. And that is the form I was asked. This is the form I'm asked. So 2x minus y equals to 6. That is the form I'm asked. And that is the equation that is perpendicular to the equation, to the line that passes through this point. Thank you for listening to me. I intend to do next topic, linear motion, and I request that to be my guests, and I think this one has been helpful to you. Thank you for listening to me.